If no, maybe we will continue to next part about the WLAN roaming. This one is a little difficult to understand. And I have a question for you. In your network, do you deploy the roaming or not? The first question. Okay, please continue next. And I have one question. The first one is, do you deploy the Fit AP in your network or not? If yes, please write down 1 to let me know it. Do you configure the Fit AP and AC in your network before or not? If yes, please write down 1. If no, please write down 2 to let me know it. Yes, it's good. Never? Okay. If you deploy the Fit AP, do you enable the roaming function on your devices or not? If yes, please write down 1 to let me know it. If no, please write down 2. The roaming function? Yes? No more? Only one guy? Okay. Now maybe let's say the wireless roaming, because in the wireless roaming we have lots of concepts. Someone maybe say, when I do the configuration on the radio cloud, it's very easy, click and to enable it is enough. But in the real devices on the AC and AP, after we enable this function, they will have a roaming table. And in this table, we have lots of concepts, and later explain one by one, and we will know the detail how to work of the principle, about the roaming. First, why we need the roaming technology? Let's see the process. If we have one AC to connect with several switch, and we have two AP1 and AP2 with connect with the network, because the signal will be reduced of the long distance, so we have some limitation of the coverage, right? Like this topology, the coverage of AP1 and AP2, there are some places is not covered. So in this scenario, and no roaming enabled in the scenario. In this topology, if you enable the roaming, it's not working because there are some places no signal, right? And once the user on movement pass through these places and there is no signal, so we will lost the connection with the AP, even no IP address, and then we cannot waste the resources. So this is the non-roaming scenario. And then you have to connect a new signal, maybe to enter the password to get an IP address again. And before you get an IP address, you cannot visit the internet because you don't have the IP address. But another one is a roaming scenario. If the coverage we have some overlap, then when the user connects with the places, I will to connect a new AP, and in this process, the IP address is not changed, and the forwarding path also is not changed. So all the time I can visit the resources. This is a function of the roaming. And about the basic concepts of the wireless roaming, if we enable the wireless roaming, that means a wireless station moves to the overlapped area, like this topology, the AP1 and AP2, the coverage area overlap. These places we call it overlapped area. And the station will associate with the new AP. And in this process, we will disconnect it from the original AP. And we hope the service are not interrupted. Maybe about the network, that means we still will use the same VLAN and the same IP, but we can we can connect with a new AP and convert the same resources. So this is a requirement. And pay attention about this process. The user at the beginning to connect with AP1, and later I want to connect with a new AP2. And in this process, the roaming is actively initiated by the station and transparent for upper-layer applications. What's the meaning? For example, about AP1 and AP2, if we enable some configuration of the roaming, and we will send a different signal power to in the wireless message to tell your station that in here my signal is too poor, and AP2 will send you my signal is good than AP1, but the choice depends on the AP, depends on the station. So if the station think this signal is enough for me to connect with AP1, the station will continue to use the connection with AP1. No, and will not choose the AP2. The AP cannot decide that to let the station choose. Please connect me. This is no choice. And I only send you what's the signal on these places in my site, and the station will choose by itself. So in some stations, you can set the parameters. For example, if the signal is lower than dash 70 and some other signal is higher, please choose to connect another one. You can set these parameters on stations, but not about your network devices on your AP. Pay attention about this part. And we are focused on after we change the new AP, the receiving message and send out trans out the message, the path is same like the original or not. We are focused on this part. And some basic concepts of the wireless roaming. And the wireless roaming type can be divided according to whether the station connects to a different VLAN or different AC after the roaming or not. We can divide this scenario into several types. Like this topology, we have two AC, AC1 and AC2. Of course, in the real network, there may be the other network here, like the network devices here. But now we use a cable director to connect with each other. And about the AC1, we have two AP, AP1 and AP2. About the AC2, we have one AP for AP3. And about the AP1 and AP2, we allow the VLAN for VLAN X. This is a service for VLAN for station. But about AP3, this VLAN is VLAN Y. And then let's see the process. If the user is roaming, and in this process, we found the connection from AP1 to AP2, and 1 and 2, both of them located in the same AC. So this type we call is intro AC. This is intro AC because they use the same AC. And this one belongs to the layer 2 roaming because your information is not changed. Both of them use the VLAN is VLAN X. And about this roaming type, intro AC layer 2 roaming, we will have one roaming devices we call is home roaming, home AP. This is roaming in AP1, and another one for the foreign AP, and this is roaming in AP. Home AP, this one we call is roaming out AP. Roaming out AP is AP1, roaming in AP is AP2. Because when you go from the AP1 to AP2, and you will connect with a new AP, this is AP2. And leave from AP1, so the home AP we also call is roaming out. And foreign AP we call is roaming in AP. AP1 and AP2. And in this process, the signal disconnected and reconnected with the AP2. And then if we continue to connect from the AP2 to AP3, then the type we call is inter-AC and layer 3 roaming. Inter-AC because the AP3 located in AC2 is different with the first AP we connected. Layer 3 roaming because about AP2 the VLAN is VLAN X, but the AP3 the VLAN is VLAN Y. And in this process, pay attention, we will have home AP, roaming out AP. This AP is AP2, not about AP1. We will use the AP2 because at the first scenario, we connect with new devices of AP2. And about the foreign AP is the roaming AP is AP3. And we also have the homing AC, we call it roaming out AC, and the roaming in AC is AC1 and AC2, because now we will connect with different AC. This is the second scenario. The third scenario is AP1 directly go move and connect and go around from the AP2. In this scenario, the signal not disconnected. We still use the connection with the AP1 and continue go around and then to connect with AP3. In this scenario, we call the type is AP1 to AP2 to AP3, and this is inter-AC layer 3 roaming, and the roaming out AP is AP1. Foreign AP, roaming in AP is AP3, and the homing AP is AC3, and the homing in AC is AC2. So why we have to know what's the roaming AP, what's your roaming out AP or roaming in AP, and also your AC type, because we have to establish the roaming tunnel with the out and in devices. So you have to know who is your roaming out, who is your roaming in. Then we will try to establish the roaming tunnel with themselves. So this is a basic concept. And then let's see the process. When you do the roaming, right? When you go through and you already enable the function of the roaming, then you use the command show mobile user and to give the MAC address. You will find so many informations. The first part is a MAC address of your station. Maybe it's your phone. Maybe it's your laptop. This is your MAC address. And here is the information. This information will show you now you are roaming. You have happened the roaming or not, and then who is your roaming in devices, who is your roaming out devices. And the RCAC and RICAC is none. That means this roaming happened and is intro AC. AC is not changed. O is out. I is in. Okay. And about the AP information, we will find the out AP and the in AP, the MAC address is different. That means we are ready to finish the roaming from the out to in, from the MAC address of 9156 to 92E3 to get a new connection. So there is a roaming information displayed on the AC. You can check it. And then when we do the message forwarding, we will add a roaming tunnel. And this tunnel information will located from these places. Maybe add the source IP address, add the destination IP address, something like this, to keep the forwarding path as the original. So this is a basic concept. And another one is when we happen the roaming, we say we will add the tunnel information. And this one is the tunnel parameters. One parameter we call is CTI, the Cap Web Tunnel Interface. And this interface is a virtual interface. You can think this is an iDesk, like the number to let you know. And now you already have several tunnels and which tunnel indicate with a different AP. And this one for the Cap Web Tunnel Interface, we call it CTI. And as the digital identity of the tunnel interface. Like this topology, we have one AC and two AP. AP1 and AP2. And we establish one tunnel for AP1 and also one cap web tunnel with AP2. And we use the CTI5 to connect with AP1, CTI6 to connect with AP2. And this CTI value only used for locally. So, like AP1 and AP2, they use the same CTI value. It doesn't matter because they belong to different AP. But on the AC, different tunnel, we have to use different CTI value. CTI value 5 to indicate the tunnel 1 connect with the AP1. CTI 6 to indicate tunnel 2 establish the connection with the AP2. Okay? And then when the data follows the traffic out, if we enable the roaming function, we will know this message now use the CT8 sends the message out and AC receive it. I will find the CT value to become CTI5. And we can use the command show LSM interface, and then you can see the index information. We will use the tunnel 1, the CTI value to become 5. And the tunnel 2, the value is 6. This is a command you can check on the AC. And also you can use the same command check on the AP. You also can find the tunnel number, and the indicate number to become 8. Indicates the local tunnel information. And another one, the CTI is the value to establish the tunnel between the AP and AC. And if the roaming happened between different ACs, we also will use indicate that we establish the tunnel in the ACs. And this value we call is MTI, Mobility Tunnel Interface. The inter-AC roaming tunnel interface value, like this topology. About the left AC, the MTI value is 3. The right MTI value is 4, because later when we show the example to you, some scenario we will change the MTI value and to make the forwarding path like the original path. Now if the data need to be forwarded out, and then the data will use this pass-through and then forward to the MT3 AC and come back to the MT1 and come back to the AP. And how to ensure the service are not interrupted before and after roaming. The first one, we have to keep the IP address does not change before and after the roaming. For example, now our phone have an IP address 192.168.1.2/24, and in your phone you open several applications. And of course, maybe you have other applications, maybe open the browser or maybe open some YouTube, some like this. And in the moving, during the moving and the roaming happens, and then if your IP address to change to become 192.168.2.1, that means all the service will be interrupted because you have to get an IP address again. After you get an IP address, you have to establish the TCP session because maybe several applications use the TCP to transfer the message. Before we establish the session successfully, all the traffic cannot be sent out. That means our resources is stop here. And then this is the first one. We hope the IP address does not change before and after the roaming. The second one, we hope the data is transmitted along the origin path. Let's see the process. If we have AP1 and AP2, and the station 1, about the AP1, the station VLAN is VLAN X. And about the AP2, the station VLAN is VLAN Y. And the station, the VLAN X segment is 192.168.1.1, the 1.0. But about the VLAN Y, the segment is 2.0. If now station connect with the AP1 and get an IP address of 192.168.1.2, and then forward the message out. In this process, if we are moving, then connect with AP2. But we still use the IP address as 192.168.1.2. And then if you connect with the AP2, and about the AP2, the whole devices only can forward the traffic for 192.168.2.0. That means your IP address not within my segment. So in this process, when I send some message out, maybe it's a DHCP request, right? Because our DHCP, we need a process we call is a reward. If the time is limited and then I want to send the message to my server, I want to continue use this IP address. And this message, we will use a DHCP request to send out. And because this request message has the IP address is 192.168.1.2, and I send to the AP2, AP2 will add the VLAN is VLAN Y, and then the VLAN Y only can be recognized for the segment of 2.0. So I send the message out. Finally, the devices will discuss this message. That's why we say we hope after the roaming, the data is transmitted along the original path. If the message still can be forwarded out from the AP1, and about the AP1, the VLAN-X can help us to forward the traffic of the segment 1.0. So this is the requirement we want to use. The actual forwarding path does not change. Of course, this is by the local forwarding. In the local forwarding scenario, an inter-AIP roaming tunnel is established to use the original path. So if you use the local forwarding about the roaming, it's very easy. In this process, if now the station uses AP1 to forward the traffic out, right? And then the traffic will be sent out through the AP1 directly to the destination. This is a path. And then maybe after the roaming, the station is moving. And then I will send out the message. And the message will be directly sent pass through the AP2. But if your station is VLAN Y, and VLAN X and VLAN Y located in different scenarios, all the code switch still will discuss your message. But if we establish the inter-AP roaming tunnel between AP1 and AP2, and then the message will be sent out through the AP2, and according to the roaming tunnel, I will send the message to AP1, and the AP1 will directly send the message to the code switch. So this red link is the path after the roaming if we use the local forwarding. And compare with the original path, of course, the roaming path will be longer. So we will take more time to forward the message out compared with the original path. But finally, the message will be not discarded. This is a local forwarding. It's very easy because we no need to let the AC to help us to forward the traffic. But about the centralized forwarding, it's a little complex because we need to send the message to AC at first, and then AC will help us to forward the traffic out. And in this process, we will use the value of the CTI to indicate different tunnel with different APs. And like this scenario about the AC, we have the CT12 to establish the tunnel with the AP2, and the CT11 to establish tunnel with AP1. And then if the user want to send out the message, the data will be directly sent out, pass through AP to AC, and then to the destination. And once the user is passed through, the message will send to AP2 and then to the AC, and AC will help to forward the message. Will help us to forward the message. And if we use a different message to connect with different AC, and this is the roaming inter AC. And if we enter the AC, we will use a new concept. We call it MTI. Because about the AC1, we will manage the AP1. AC2, we will manage the AP2. And at the first, the data will be transferred from the AP1 to AC1 and then to the destination. And then when we're moving to connect with AP2, the message we will send out. But now we connect with the AP2, and the AP2 is managed by the AC2. So between AC1 and AC2, we have to establish the inter-AC roaming tunnel. And how to establish the tunnel, we have to add the configuration. And after we establish the tunnel successfully, we will have the MTI value to indicate different tunnel interface. The right one, the MTI value is 1, and the left one, the MTI value is 2. Then the message sent out to AP2. Then the message will send to AC2 at first. AC2 will send out to AC1, and then AC1 will send the message again. So this is the inter-AC roaming tunnel will be used if the AP is managed by different ACs. And how to make sure that the IP address is unchanged? You have to change the VLAN ID of the station. Pay attention about this scenario. If two APs located in the same AC, in this scenario, they will have different VLANs. For the local forwarding, I will directly send the message out, choose the best path. And then, when we're moving to another AP, we will establish the inter-AP roaming tunnel. And the process is, I will send the message out and to AP1. Then AP1 will change the VLAN ID from the Y to X. So for all the network devices, we'll think now the message already carries the VLAN is VLAN X, and then AP will send the message out again. So this is the path we will send out the message. In this process, the AP1 have a function directed to change the VLAN ID to make sure the IP address is unchanged. So this is a local forwarding. So compare with the different type of roaming, we can divide the roaming to become intra-AC and inter-AC. And depends on the new AP, the VLAN and the IP address is the same or not. We also can divide to become layer 2 roaming or layer 3 roaming. In this process, about the local forwarding, it's very easy. The first, because local forwarding, when we follow the traffic of data plan, of data tunnel, we don't need to let the AC to help us to follow the traffic. So we no need to make any connection with the AC. Only between different APs establishes the inter-AP roaming tunnel successfully. When the user connection movement, and then to let the home AP to help us to follow the traffic, it's enough. And the home router will change the new VLAN to become the older VLAN, and then we can directly to send the message out. So about the local forwarding, it's very easy. But about the centralized forwarding, it's a little complex because we have to establish the connection shape with the AC. If intra-AC, we change the CTI value is enough. When we follow the message, we will check the roaming table and check your CTI value is the same one or not. If not, I will change the CTI and then forward the message out. When we receive the message from the AC, I will change to become a new CTI and then send to the new AP. So in the intra-AC centralized forwarding, we will change the CTI value. And about the layer 3 roaming, in the inter-AC, we will we will establish the inter-AC roaming tunnel between different ACs, and then we will use the MTI value, and finally to forward the traffic and keep the same forwarding path. But about how to make the IP address does not change. About the layer 3 roaming, layer 2 roaming is very easy because layer 2 roaming we have the same VLAN and the same IP segment. About the layer 3, we will directly to change the VLAN ID. So this is a summary of the VLAN ID, CTI, and the MTI value. About the MTI means we will establish the inter-AC roaming tunnel with each other. And here we will see a detail of the example how to work it. If we have the layer 3 roaming in local forwarding within the AC, we have call switch, we have AC, and we will have two APs, one for AP330 and another one for AP320. And we have one IP, one station, the IP address is 192.168.3.1. And here is the IP address of the AP. And another API IP address is 127.3. And in this process, once the day one want to send out the message, the destination message IP address is 1112.114.114. Source IP is the IP address of the terminal of the station. Then the day one at first will send the message out. Send to AP330, right? And then the AP330 will add the VLAN because we belong to the VLAN 3. And this message will become a new message. We call it the day 2. And then the message will be sent out to the call switch and finally to the destination. And in this process, if we connect with new devices, and because this is a local forwarding, so between two APs, we will establish the inter-AP roaming tunnel. And after we establish this tunnel, we will find some message about the roaming information. The ROC is out AP. RIC is in AP. And MTI and CTI, because this is a local forwarding, so this one is not useful in when we transfer the message. The source VLAN ID is 3, destination VLAN ID is 2. This is the information of the 330 because the source is the VLAN 3, destination is VLAN 2. And the WLAN ID is 1. This is a configuration we add on the AP. And the peer MAC address and peer IP address, this is the information of the 320. And here is the part information in the AP320 about the AP330. So after we establish this tunnel on two APs, we can see the roaming table information. And then when we connect with the AP320, and still we will use the origin IP address. Then let's see the process, how to encapsulate the message according to the roaming table and forward successfully. This message also will send out the destination is 114, right? Source IP address is the laptop IP address. Then the message will be sent to the AP320. And we will add a VLAN. This VLAN is VLAN 2. Why we add the VLAN 2? Because now we connect with AP320. And then we will add the destination and the source IP address. These two IP addresses come from the roaming table about these two parts. Because now I know this is a roaming message. I will add this source and destination IP address. One from the AP330 and one is AP320. And this is a new date for date 4. Then the message will be forwarded out according to layer 2 information to the AP330. About AP330, I will delete this information, right? And then I will immediately to change the VLAN from VLAN 2. I receive the VLAN is VLAN 2. I will change the VLAN to become VLAN 3. And later, this is a new message, div 5. I will send the message out to call switch. And when the message reply and carries the destination to become 192.168.3.1, the source IP is 114, and this message will carry the VLAN 3, right? Because at the beginning I received the message, this message carries the VLAN 3. And according to the VLAN 3, the message, the date 7, will be sent out to AP330. And then the AP330 also will found. This terminal now is located on the AP320. So I will add the source and the destination. And this is the tunnel information of the roaming. And this tunnel will help us to forward the traffic to the right AP. And when the right AP receives it, I will delete the source and the destination. And then I will make the VLAN from 3 to 2. And finally, send the message to the station. So this is a whole process that how to forwarding on the local forwarding mode. In this process, we will establish the inter-AP roaming tunnel between the AP directly. And we will getting the roaming table information. And when we receive the message, I will directly change the VLAN information to keep the station use the original IP still conveys the destination. So this is a layer 3 roaming in the local forwarding. It's easy for you to understand, right? Okay. And about the inter-AC, especially in the centralized message, in the centralized forwarding scenario, we have to establish the inter-AC roaming by the command. We have to create the mobility group, and then this group will help us to establish the tunnel between two ACs. This is a key configuration. AC mobile group and gives a name, and to tell you what's a member in the group. What's a member on the group? Like the command on the AC1, we create the name to be, the name is my mobility group, and tell you in the group you have AC2 and AC3, and about the AC2 is same. You can give the same group name or different, it doesn't matter. And what's your member? AC1 and AC2, AC3. And about the AC3, you also have two members. Then we will have the relationship of the MTI value and also includes with the CTI. Then we can help us to follow the traffic inter-AC roaming. Also here is an example. If there is a layer 3 roaming in centralized forwarding between ACs, and we will have AP1 and AP2 connect with different ACs. And about AC1 and AC2, we establish the roaming tunnel. Use the MTI value, MTI4 and MTI3. And about the AC1, we use the CT1 to establish the cap-web tunnel between AP and AC. And another AC, we use the CTI value is 2. This is only is an example. Maybe in the real network, these two CTI value will be same. It doesn't matter. Then let's see the process. About AP1, now we are roaming, right? And about the AC roaming entry, we will find AC1 is the outer router. This is out AC. And the AC2 is in AC. And the MTI value is 4, CTI value is 1, and the SVID is 1. This is a source ID. The source ID of AC is VLAN 1, and the destination VLAN is VLAN 2, and the WLAN ID is a configuration. About your AC2, the MTI value is 3, CTI value is 2 to indicate now I establish the connection with AP2. And the source VLAN is 1, the destination VLAN is 2. This is the process. Now the data needs to be forwarded out. Then the message will be sent to the AC2 at first. And about the AC2, I will find at first this is a roaming message, right? And then the message will be sent to AC1 according to the roaming entry. The tunnel inside, the outside is the AC1 information. The CTI value is 4. Then the ACI will send the message to AC2, and then the AC2 will come back to the AP2. So in this process, when the message is sent out, I will send to AC2, AC2 will send source to the AC1, and the AC1 will help us to forward the traffic. When we get the message reply, we will send the message to AC2, and also we will change the MTI value to become 3 and to the AC2. AC2 will give the reply to AP2. So in this process, not only considered about the CTI, we also have to consider about the MTI to check that we belong to different ACs. Okay, so this is the process how to make the layer 3 roaming in the local forwarding or in the centralized forwarding. And in some scenarios, there is no need to disable the roaming. For example, in the layer 2 network, layer 2 network means AP1 and AP2, they will have the same VLAN, VLAN X. And when the user is working, they will connect a new AP. And if you enable the roaming in these devices, they will establish the internal roaming. They will establish the inter-AP roaming tunnel. After we establish the tunnel, then the message sent out to AP2. AP2 will send out to AP1 and then to send out. And this is the path. But in this scenario, if we not enable the roaming, the message sent out to AP1, I will directly send out. But if the user working, then I will connect with AP2. AP2 also can directly send out. And compare the right one and the left one. This path is better for us to follow the traffic. The first one, the path is better. The second one, we no need to forward the message to AP1 and let AP1 to help us forwarding. If the traffic is very big, this is a big pressure for the AP1. AP1 need a higher performance to help us to forward the traffic. So in the scenario, for example, maybe in your school or maybe in some places, the places is very big. The place is very big, and we need a lot of AP, several AP to coverage the signal. And all the AP configuration is same. So you can think this is a big AP. So in this scenario, we will use the same VLAN, use the same segment, and can forward out. So in this scenario, you don't need to enable the roaming. But if you deploy different SSI, different VLAN for different maybe terminals to forward out and connect with different APs, in this scenario, you have to enable the roaming. So pay attention about this part. That's all about the WLAN roaming. And this part, we talk about lots of concepts. And now, do you have any question about these two parts, the filter AP and the AC, and also the roaming?